Hello and welcome back, everyone. In our today's session, we're going to start a new topic. We're going to have a discussion regarding air fault protection in three-phase motors. Okay, guys, let's assume that we got a three-phase motor. It's working, it's running, it's getting this incoming electrical current, I1, 2, and 3 from our three-phase system. Now, in such case, in such situation, we usually say that we have a balanced current. Now, guys, for any sort of reason, let's say the coils that we got and the motor itself are interacted with the panel of the motor and then with the earth, okay? This way, a fault current would be created. In this situation, in this case, that a fault current has been created, we say that we have an unbalanced current. Now, an unbalanced current could cause the motor to overheat, and for example, this could ruin your coils completely. Now, guys, to protect our motor from, against these unbalanced currents or these false currents, we actually need to use some new devices, some new equipments. The first device that we can use would be core balanced current transformer. We've actually seen its abbreviation before, CBCT. Now, when we want to connect our three-phase system to our motor, the electrical currents should actually move through our CBCT transformer. And by the way, a CBCT transformer has a shape like this. Now, what is the duty of this equipment? We said that we would have a current coming from these phases, I1, 2, and 3. When the current becomes unbalanced, more specifically, when we have a fault current in our three-phase motor, we would get a small signal, for example, here. And well, obviously, through this signal, we would understand that we are actually having this air fault in our motor. Okay, moving on to the next slide. Guys, if you remember, when we were discussing MCCB breakers, we said that inside these breakers, an equipment would be set called Shunt Trip. Now, if we connect a signal to both sides of this relay here, let me point them out, talking about these two, okay? This could cause the MCCB breaker to be set on the trip mode. I write it down. Now, guys, the thing is, we can use all of these mentioned equipments. CBCT transformer, Shunt Trip, and also MCCB breaker for further protection regarding our motor. How? Let's see. Let me move to the next slide. All right, take a look at what we have here. We got some electrical symbols in this diagram. For example, this one is for the MCCB breaker as it is written actually. And then up here we have the three phases, L1, 2, and 3, which are connected to the breaker. And then, as I said, the electrical current would move from the breaker and right through the CBCT transformer and all the way to the three-phase motor. And well, as you probably already know, we have the earth down here. More precisely, the connection in between the motor and the earth. Alright, back to our discussion, guys. Let's say for any reason, a fault current has been created. In other words, we have an earth leakage. In this case, a very small current would be created in between the motor's frame and the earth. Now, because of this leakage, because of this current leakage, we would get a signal on both sides of our CBCT transformer. Now, the CBCT transformer would be connected to this relay called earth fault relay. And now, through the outgoing current of this air fault relay, the shunt trip set inside our MCCB breaker would be activated. In other words, the breaker that was actually on so far would immediately be set on trip. And well, as a result of this, the electrical current would be cut off and our three-phase motor would stop working. It would be turned off. Right, guys, so basically, this is how you can protect your three-phase motor through using equipment such as MCCB breaker, CBCT transformer, air fault relay, and also shunt trip relay. Now, guys, we are also able to do something else. Let me change the slide. Okay, guys, take a look at this diagram. The thing is, sometimes inside the relays, we would find a normal closed contact, like this. All right, now, once again, the three phases L1, 2, and 3 would move through the MCCB breaker, and then they would enter the CBCT transformer right in the middle again. Then they would be connected to the contactor, and from the contactor to the motor. Now, let's say the CBCT transformer is giving this signal, and the signal is actually connected to the air fault relay. And as I said, inside the relay, we have this normal closed contact that is actually set in our control circuit electrical currents path. So as a result, guys, we can simply use this start push button here to activate this contactor. Okay, now guys, once more, for any kind of reason, it doesn't matter what, if we ever got any fault current, we would get this signal here, more precisely, a positive signal here. And this positive signal causes the normal closed contact to be opened. And then the electrical current would be cut off, the contactor would stop working, and as a result of everything, the motor would be turned off. And yeah, guys, basically this would be another method that we can use for applying further air fault protection in our three-phase motors. Now, let me give you an example. I'm going to show you a real diagram on regarding this whole concept. Okay, we have this diagram for a real control circuit. Up here, we have the three phases entering our electrical panel. Then here we got this manual switch. After that, we have this MCCB breaker. And then the transformer, the CBCT transformer. And well, obviously the transformer is being connected to the air fault relay here. And well, there's this contactor here that we would use for turning on the motor, the three-phase motor. Okay, what else? We have this overload relay, that's bimetal. And also we have the CBCT transformer signal that would be connected to the air fault relay. And also, as I said, we have this normal closed contact set in the air fault relay. And the address that we have for the terminal set in this contact would be 0/J9. Alright, and the address is actually pointing towards this point here. We talked about this before. Based on the zones, we have J9. So guys, when the CBCT transformer gave us a signal, the air fault relay would be activated. More specifically, its normal closed contact would be opened. And as a result, the signal to the contactor would be cut off, and well, obviously, the contactor would stop working. Alright guys, so basically, this would be how exactly you can use equipment such as CBCT transformer and also air fault relays regarding the matter of air fault protection in three-phase motors.